Hello and welcome back to another IB Math Speedrun with me, Vince. In this speedrun, we're going to be going through paper 2 of the IB Math textbook, so let's jump right in. So, again, I'll be doing the odd ones, so this time around I think we can use a calculator, which is quite helpful. So yeah, you need a graphical display calculator, or alternatively, a scientific one and some harder methods. So let's go. First, the random variable x is normally distributed with mean equal to 8. Given that the probability that x is greater than 7 is equal to 0.69146, find the value of the standard deviation. So, knowing this, we know the probability that x is greater than 7, and in other words, z is greater than 7 minus 8 over the standard deviation is equal to 0.69146. So this means 7 minus 8 over the standard deviation should be equal to, and let's reverse search this through my table. I get that this is around equal to 0.5. So if we have, actually this should be negative 0.5. So we have negative 1 is equal to negative 1/2 of the standard deviation, so a standard deviation should be equal to around 2. Yeah, that was it. Okay, cool. So we have a standard deviation of 2. On to the next one. And the next one, we have an object is initially at the origin. It moves in a straight line with velocity v meters per second, given by v is equal to 5 sine t squared, where t seconds measured in radians is the time which has elapsed. Wait, what? Okay, so measured in, okay, fine, measured in radians. So first, write down the initial velocity of the object. And then next we have find the total distance that the object travels in the first 3 seconds. And then finally we have find the displacement of the object from the origin when t is equal to 3. Okay. So initial velocity of the object is equal to 5 sine 0, so the initial velocity should be equal to 0 meters per second. Since velocity is equal to 5 sine t squared. Hello, sorry, I'm back. So to find the total distance, well, we would normally have to integrate this function, but integrating 5 sine t squared is outside the scope of the IB Math syllabus. So instead, we can use a calculator, or Desmos for me, to calculate this, and we need to get the absolute value of the function, the integral of the absolute value of the function between 0 and 3, which turns out to be 8.51 meters. Finally, find the displacement of the object when the time is equal to 3. Well, we can do it on the graph, or we can solve it. It's going to be 5 sine 9. 5 sine 9 radians is equal to 2.06 from my calculator. hold on. Displacement of the object when time is 3. Oh, sorry, that was the velocity. So to find the displacement, we actually have to integrate it, but without the absolute value functions. So we end up with 3.87 as the answer. So we have 3.87 meters as the displacement and 8.51 as the distance traveled. Okay, nice. So next question, we have a function is given by f of x is equal to e to the power of x to the power of 2. So first calculate the area of the region bounded by y is equal to f of x, y is equal to 0, y is equal to 1, x is equal to -1, and x is equal to 1. And finally, this region is rotated through 2 pi around the x-axis. Find the volume of the solid generated. Okay, so we have calculate the area bounded, so we need to calculate more or less the area between -1 and 1, ex squared. Yeah, so this shouldn't have any zeros, so of just ex squared dx. So just like the last integral, it's actually impossible to find the area of this solid without using our handy calculator tool. So in our case, this function looks like e to the x squared, or looks like this. And so we need to find the region bounded by more or less this integral over here, or the absolute value of it. So if we have the absolute value of this integral instead, between, I think it was 1 and -1, that's around 2.93. So we got this is equal to around 2.93. And so if we rotate this through 2 pi around the x-axis, we need to find the volume of the solid generated. Okay, so to find the volume of the solid around the x-axis, we need to integrate this squared. So e to the x squared squared, which is e to the 2x squared, I think. Yep. So dx. So this will be equal to, again, let's just change this to 2. So we have 4.72, and then we have to multiply this all by pi. So I got around 14.85 or 14.9 as the answer. Yeah, okay. So on to the next question. And the next question is a discrete random variable satisfies the binomial of 2 to the n and 1/2 distribution. So first, by considering symmetry, write down what the mode is. And next, given that the probability that x is equal to the mode is equal to 35 over 128, find n. Okay, so first, the mode is simply equal to n. Since we have a 0.5% chance that the event will succeed or fail, then by symmetry, this should be symmetrical around the mode, so the mode should be equal to half the number of trials, which is n. So given the probability of x is equal to the mode is 35 over 128, find n. So more or less, we have 2n, choose n, times 0.5 to the power of 2n is equal to 35 over 128. 2 to the n choose n is equal to 2n factorial over n factorial squared. And so the probability that x is equal to the mode is equal to 35 over 128. Is this not just n equals 8? Let us find out. So mode is 35 over 128. So 2 to the n, 2n factorial over n factorial squared times 0.5 to the power of 2n is equal to 35 over 128. And in other words, what is this? 8 choose 4. Yeah. And so if we substitute in n equals 8, I mean, just looking at it, this looks oddly suspicious as 70 over 256, which is, of course, this is 2 to the power of 8, and this is 8 choose 4. You don't have to memorize this, just playing around with it gets you that. And so we have n is equal to 4. Sorry, not n equals 8, n equals 4, because 2n, it was 0.5 to the 2n. So n equals 4. Okay, very nice. On to the next question. And that one is, we need to consider a system of equations the system of equations x plus 2y plus 3z is equal to 7, 4x minus y minus z is equal to 6, and 5x plus y plus kz, sorry, not kx, 5x plus y plus kz is equal to 12. So find the value of k for which there are no solutions, and b, for k is equal to 1, find the solution. Okay, find the value of k for which there are no solutions. So, so if we subtract the third equation from the, if we subtract the first equation from the third one, we get 5x plus y plus kz is equal to 12. And if we subtract x 2 plus 2y plus 3z is equal to 7, we get 4x minus y plus k minus 3z is equal to 12 minus 7 is 5. And so we have an exact one here, which is 4x minus y minus z equals 6. So we actually need to have two parallel equations that have different constants to make this unsolvable. Therefore, k minus 3 must be equal to the coefficient of z in the second equation, which is negative 1. So k must be equal to 2. So that's that. And then next solve it for k equals 1. So we have x plus 2y plus 3z is equal to 7, 4x minus y minus z is equal to 6, and 5x plus y minus plus 1 plus z is equal to 12. So again, we can rearrange this, and we can, from this bottom one, we subtract it. So we have 4x minus y plus minus 2z is equal to 12, and 4x minus y minus z is equal to 6. So therefore z is equal to 6. Okay, plugging the rest in, z equals 6. Now we need to simplify to an equation with just z and another one. So if we add these two, if we multiply this one by 2 and add these two up, we get x plus 2y plus 3z is equal to 7, and 8x minus 2y minus 2z is equal to 12. So therefore 9x minus plus z is equal to 19. Since z equals 6, oh wait, did I write the equation wrong? Wait, something's wrong. K equals 1. 5x plus y plus 1 is 12. This minus that. Oh, this should be, yeah, negative 2z equals 12 minus 7. Oh, this is 5. Oh, oopsies. So we actually have z is equal to 1 here. (4x plus minus 1 minus 6). Yeah, so z equals 1. And then we have 9x plus z is 19. So therefore 9x equals 18, so x is equal to 2. And then finally for y, we have, let's just take x, so 2 plus 2y plus 3. So 5 plus 2y is 7, so y is also equal to 1. So these are our answers. Very nice. Okay. And then let's move on to the harder questions. And so the harder questions look something like this. So a function is defined by f of x is equal to 6x plus 3 divided by 2x minus 10, for x is not equal to 5. So first, A, write down the equation of the vertical asymptote and next write down the equation of the horizontal asymptote. Next write down the y-intercept and write down the x-intercept. And then next find the derivative, so f prime of x, and then state what this tells us about the graph of f of x. Finally, sketch the graph of f of x and write down the equation of the tangent to the curve at x is equal to 2. Okay, first of all, vertical asymptote is simply x equals 5, since that's what the function is not defined for. And also, when this function tends to 5, the function tends to infinity. Next, write down the equation of the horizontal asymptote. So we need to find the limit as x tends to infinity of 6x plus 3 over 2x minus 10. So if we divide everything by x, this is equal to 6 over plus 3 over x over 2 minus 10 over x. As this tends to infinity, that tends to 0, that tends to 0, so this entire thing tends to 3. So the horizontal asymptote is y is equal to 3. Next, write down the y-intercept. Well, when y-intercept is when x is equal to 0. So we have 3 over negative 10, so negative 3 over 10. And we want to write down the x-intercept, and that's when y equals 0. So we have 6x plus 3 equals 0. X is equal to negative 1/2. Find the derivative. So we need to find 6x plus 3 over 2x minus 10. We need to find a derivative of this, which we can do using quotient rule. So this is equal to 6 times 2x minus 10 minus 2 times 6x plus 3 all over 2x minus 10 squared, which is equal to 12 minus 12, so that's 0, so it's just negative 60 minus 6, so negative 66 over 2x minus 10, so that is the derivative. And state what this can tell us about the graph. It means that this is a decreasing function. Since there are no positive values for the derivative, this is going to be decreasing. So the graph is always decreasing. So if we want to sketch this graph should look something like, let's draw our axes. And we need to also, sorry, I mentioned it in the question, but I didn't write it down. We need to reflect this information. So we need to reflect that we have an asymptote at x equals 5. So does not touch this line. And y equals 3. So this line, there would be a line here, that's asymptote. That the y-intercept is negative 3 over 10, and the x-intercept is negative 1/2. So it's going to cross the two lines here and then come up here. So it's going to look something like this. Yep. So this is negative 3 over 10. This is negative 1/2. This line is y equals 3. This line is x is equal to 5. Not to scale. And it's always decreasing, as you can see. Finally, write down the equation of the tangent to the curve at x equals 2. So if we find the tangent at x equals 2, the gradient will be equal to negative 66 divided by 4 minus 10 squared. So 6 squared. So 36. So this is equal to negative 11 over 6. So that's the gradient. So we have y is equal to negative 11 over 6x plus c. We need to find the y-coordinate at this point on the curve. So we have, when x equals 2, we have 15 over 2 times 2, 4 minus 10, 6. So this is the y-coordinate. So we have negative 15 over 6 is equal to negative 11 over 6 times 2 plus c. So we have c is equal to 22 minus 15 over 6. So that's equal to 7 over 6. So y equals negative 11 over 6x plus 7 over 6 should be our equation of the tangent to the curve at that point. Yeah, so this looks good. Okay, next question. And final question. We have a final question, come on, text please. We have a continuous function, a random variable, has a probability density function defined, and I'll write it down. So first, find the exact value of a. Next, for this distribution, find the mean and the variance. And finally, given that x is greater than 0, find the probability that x is less than 1/4. Okay, interesting. So let me write out the definition. And the definition is f of x is 0 if, this is a pretty bad definition, it's just a cosine of pi x, where x is in radians, if negative 1/2 is less than or equal to x is less than or equal to 1/2, and 0 or otherwise. So to find the exact value of a, we need to remember that all of these, the integral of the entire thing should equal 1, or the area under the curve should equal 1. So the integral between -1/2 and 1/2 of a cosine pi over x must equal 1. So we have here dx, of course. So we have the integral between 1/2 and -1/2 of a over pi sine pi over x, pi x, is equal to 1. So this is equal to a over pi 2 times a over pi, because sine pi over 2 is 1, and then yeah, so just 2a over pi equals 1. So a equals pi over 2. Interesting. Okay, a equals pi over 2. Nice. Okay, so next we need to find the mean and the variance. So we can get the mean by getting the integral of x times the function dx between the bounds. So this will be equal to integration by parts. We have pi over 2x cosine pi over pi x. And we could do it using a calculator, but that's the easy way. Because this one looks like it's actually doable by integration by parts, dx. And so this is equal between -1/2 and 1/2. So if we have u is equal to, I guess, 1/2 x. U prime is equal to 1/2. V prime is equal to pi sine x. Pi sine pi x. Is it sine or cosine? Oh, it's cosine. What am I doing? Sine was the derivative. Anyway, it should be cosine. So V must be equal to sine pi over x. Pi x, sorry. So this should be equal to 1/2 x sine pi times x minus the integral of 1/2 sine pi x, which is plus 1 over 2 pi cosine pi x. So the integral, the bounds are -1/2 and 1/2, so we have So we have 1/4 sine pi over 2, so this is 1/4, plus 1 over 2 pi times cosine pi over x, but pi over 2, cosine pi over 2 is equal to 0, so that's 0. -1/2, so we have plus 1/4. So is the mean just 1/2? Oh, but this is minus, so this is 1/2, 1/4 minus 1/4. And then this is 0 again. So 1/4 minus 1/4, so the mean is actually 0. So that's very interesting. So the mean is 0, but what is the variance? And so the variance, we need to find the integral of x squared times this. -1/2 and 1/2 of x squared, pi over 2 x squared, cosine pi x dx. This does not look fun. This is a double, so this is u is equal to 1/2 x squared, u prime is equal to x, v prime is equal to pi cosine pi x, v is equal to sine pi x. So we have 1/2 x squared sine pi x minus the integral of x sine pi x. So again, integration by parts. We have u is equal to x, u prime is equal to 1, v prime is equal to sine pi x, v is equal to negative cosine negative 1 over pi cosine pi x. So we have minus uv, so that's plus 1 over pi times x cosine pi x minus the integral of, so this, in this case it's plus the integral overall of negative 1 over pi. So this is going to be equal to minus 1 over pi squared sine pi x. Oh, sorry, you can't see that. Okay. And so if we have 1/2 as the bounds, we can immediately exclude this term. So we have 1/2 times 1/2, so 1/8, minus 1 over pi, and then we have, this will be plus 1/8 plus 1 over pi squared. What in the world? Or is this minus 1 over pi squared? Yeah, this should be minus 1 over pi squared again. So what in the world is this equal to? This is equal to 0.25, 1/4, minus 2 divided by pi squared. So I got something like 0.0474 as the variance. Okay. And of course, this is the variance because we should be subtracting the mean squared, but since the mean is 0, this is the variance already. Finally, given that x is greater than 0, find the probability that x is less than 1/4. So we need to find the probability that that this variable is less than 1/4, and divided by the probability that this variable is greater than 0. So the probability that the variable is greater than 0 is I'm pretty sure it's just 1/2 or 0.5, since this is an even function. Yeah, because cosine is an even function. So this should be 0.5. And so what's the probability that x is less than 1/4? Well, I guess we can just find the integral that the probability is greater than 1/4. So integral between 1/4 and 1/2 of this function over here. So we have, we already have the upper bound, so that's just a over pi, which is, a is pi over 2, so this is 1/2, minus the lower bound. So the lower bound is 1/4, so that will be 1/2 sine pi over 4. Sine pi over 4 is root 2 over 2, so this is minus root 2 over 4. So that's around 0.146, so we're getting 0.146. So this probability is around, okay, so this is equal to the probability of A intersection B over the probability of A. Or A is, of course, the chance that's greater than 1, or 0.5. And A intersection B is the chance that it will be between 0 and 1/4. Oh, so actually what I needed is root 2 over 4. So this should be root 2 over 4 over 0.5. So root 2, so 2 root 2 over 4. So that's around 0.7, actually. It's quite a high probability. Yeah, it's around 0.707. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. So hopefully we'll go through some more tests. I think it's the final test next one. So let's see you then.